Okay, by the end of the hour, I want to make sure that you know all the basic properties of exponents. I want to make sure that you can change bases like we did yesterday. And then I'm going to teach you some new stuff about solving equations using exponent properties. I'm going to pause for a second and see if everybody's in the right spot. So we are moving on to this slide. Everybody get there. And this should be a no-brainer for you. Would you please tell me what this is? X to the what? Turn it my way. I'll tell you yup or nope. Should be done by now. Rapido. Yup, 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 yup. Okay, good. Let's move on. This one. Something a little different there. Zoom in, please. It's nice and bright, but I still can't see it because I'm old. Yup, 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 yup. Mr. B, I still haven't seen an answer from you. Hurry up. Yup, yup. Yep. Nope. Yup. Okay. All right. This one. Simplify without negative exponents. Just tell me what the exponent is verbally. All right, to the 12th. Good, you multiply in that case. If you had forgotten, can anybody remind me of what I said to do? If you forget, like, should I multiply these or should I add these? Because that's the biggest confusion. Yes, sir? Like that? And how does that tell you? Because right now your choices would be it's either the 7th or the 12th. And how does this help?
Well, there's no way the 7th could work there.
Yeah. This just doesn't make any sense. If I have 4 sets of these, there's no way 7 could make any sense. All right. Good. Let's move on to this one. X to the what? Say it out loud. X to the 3rd. Good. How about now? Why didn't you say x to the negative 5? Because that's this minus this, just like last time. Huh? What? Why? Oh, yes. We described this as not being happy because it's negative. And we got to make it happy, and it's not happy in the upstairs condo, so we got to bring it down to the lower level where he doesn't have to walk up the stairs. We talked about my dad and his condo in Florida. All right, so 1 over x to the 5th is a better answer than x to the negative 5th. They're both true, but one of them, notice, without negative exponents. It's better to have this one then. Okay, good. Next kind, what's that? 1 over x, good. You need to be really fluent with these. What's that one? Ooh, not 3 over x to the 3rd. 1 over x to the 3rd is correct. Okay, how about that one? Rewrite this with an exponent, as in something to the something. I'll give you a hint. One of them's 2 to a power. Yep, 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 yep. Something's kind of fishy over there. Yep. You can still blame your iPad? Oh, yeah. Okay, yeah. Okay, good. Good. Oh, there's a new one. Mr. T, tell me what you did different. 4 to the negative 1. Notice how it says 2 options. Everybody else was giving me 2 to the negative 2, but 4 to the negative 1 also works. And you could just get picked based on the problem. Like if you wanted to make a problem that had the same base as another problem, if you had a problem where you had on the right side equals 2 to the x power, then you would know, oh, I want to make these bases the same as each other, so I'll choose the option where I rewrite this with a 2 to the negative 2. If the problem had instead had a 4 over there, hold on just a moment, technical difficulties. If instead there had been a 4 right here to the, let's say, 3x, then you would rewrite these to both have the same base. And I'd like you to do that one, please. I just changed the problem a little bit. Solve that. In the end, that means tell me what x has to be. Make them have the same base. I'm going to check it for you. I will. Hold on just a second. Let me think. Tell me what you thought again. I think you're right. Yup. 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 Got it? You got started. All right. Oh, yesterday, that was a big key lesson. All right. Where could you learn that stuff that you learned yesterday, that you missed yesterday? Any idea where you could learn that stuff that you missed yesterday? Yeah, that's right. Good, 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 good. Okay, so I'm seeing lots of people doing this right. This is 4 to the negative 1, and this is 4 to the 3x. And the beauty of that is that this now has to equal this. If they have the same bases, then their exponents have to be equal. Negative 1 equals 3x, and then you divide by 3 on both sides, and you get x equals negative 1/3. Okay, moving on. That one, rewrite it with an exponent. There's 2 different ways you could do it. Something to the something, and something else to the something. Do both ways, please, this time. Yep, yep. That negative is confusing me, but other than that, yep, 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 yep. Wait a minute, it's not to the 3rd. It's 2 to the something else. Yep, 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 yep. Except it's not to the 3rd, it's 2 to the something else. A lot of people thought this was 2 to the 3rd. What is 2 to the 3rd actually? And so it's actually 2 to the 4th. Very good. Otherwise, it could be 4 to the 2nd. All right, moving on. This one, if I want to get x squared to equal 16, would you agree that x has to be 4? All right. Ooh, there we go. I was hoping somebody would call that because this one is the most commonly made mistake in pre-calc, is losing a solution. People forget about the other solution. Yes, 4 works, but there's another answer. Let me remind you why this happens. If I take a square root on both sides, I end up with the square root of x squared, which everybody thinks is just x, and the square root of 16, which is 4. That's why they get it wrong. What is actually wrong here? It's not the 4. What do I need in this problem that I haven't got? Absolute values. Very good. The square root of x squared is the absolute value of x. Really common misunderstanding. Okay, now, if that's true, then what's underneath the squiggle here could be either what? Plus or minus 4 would work. You get how if I put a minus 4 in there, it works? All right, so that's the crux to the problem, is there's 2 things that could work here, and most people only give 1. X equals 4 is one of my answers, or x equals negative 4 is one of my answers. All right, notice, when did that happen? Because why am I bringing this up? It's going to happen again today. What makes you put in absolute values? When you do what? Square root. Does that mean anytime there's ever a square root problem that you have 2 answers? No. Notice, I did a square root here. Square root of 16 is just 4. There's no plus and minus on that side. The square root of 16 is 4. It's not 4 and negative 4, because the square root of 16, this little symbol right here, means principal square root, means positive square root. So it's the square rooting of a variable. That's what you look out for. If you ever do a square root of a variable, you just caused yourself a problem if you didn't bring in the absolute values. Okay, so I need to do another one like this to show you what I'm talking about. Add a blank page and try this one. X to the 3rd is equal to 8. If I'm supposed to solve this, last time we just did square root on both sides. We can't really do that, can we? What can we do? Cube root. Now, instead of putting this, saying cube root, that is the cube root sign. Instead of doing that, though, usually there's a more professional way to do it. Does anybody have a suggestion? How I could get this thing, this x to be an x to the 1? Sure. What should I do with that? Should I just make it a negative 3? Is that what you're saying? What do you think? I need to do something to both sides to fix my problem. Yes, sir. So somehow a 1 over 3. I agree there's a 1 over 3 involved. Can you be more specific? So I should times by x to the 1 over 3? You're warm, but not right. Yes, sir? 8 to the 1/3, so you're saying I should put this to the 1/3. It's still x to the 3rd. You're really close, Mr. P. Come on, finish the deal. Yes, sir? Exactly. If you do it to this side, you have to do it to this side. You have to do it to both sides equally. That's what we always do on equations. Do it to both sides. Okay, so you put it to the 1/3 power. Do you remember that yesterday I was talking about how these fraction exponents mean that's the roots down there? Those are the roots. So I just took it to the 3rd root. Is that like that thing I just did before where I square rooted both sides? It's a little different. I cube rooted both sides. You all understand that the square root of a negative gives you a problem, right? What kind of an answer is that? Imaginary. So it's not a real answer. Okay, so it's the square root of -8 is a problem. Is the cube root of -8 a problem? No, because I can actually have an answer for that. What is the answer to the cube root of -8? What do you think it is? A little louder. -2. Because why? Because -2 times -2 times -2 makes -8. So it's totally okay to have a negative under that kind of a root because I can answer the question without any problem. The reason this is not okay is because you can't figure out any number, normal number, that would work. Because 2 times 2 would make 4, not -4. And -2 times -2 also doesn't make -4. So you can't find an answer to this. That's why you have a problem there. You can do odd roots. This is an odd root. You can do odd roots and not have any problems. What you will have trouble with is when, and I know some of you are going to forget this, and you'll lose a half a point twice on the test because you won't remember that if you take the square root on both sides, that you've got to remember the absolute values. Let me show you how that could look different. You saw this one just a second ago, and now I'm going to go like this to it. Do you get that I just did the square root, but it looks different? To the 1/2 power is the square root. I just square rooted both sides. And a lot of kids are going to go like this and forget a solution. Do you get how I just dropped a solution? Should be absolute value of x equals 4. Because I just square rooted a variable. Just as if I had started this problem and went like this. Do you get how that square root symbol? Exact same thing as putting something to the 1/2 power. So I'm trying to keep you from making these little mistakes. Math has so many options to make little mistakes, and it's usually involving negatives. I would bet you that I could find kids in my pre-calc class that have single-handedly lost 2 full grades from A's down to C's simply based on negative signs. Seriously. So it's that big of a deal. You could drop your grade 2 full grades in pre-calc by not being careful with your negatives because they're all over the place. And you forget one, you forget a solution, it's wrong. It's not partial credit either. It's just wrong. All right, so trying to reinforce how important it is to remember these negatives. All right, let's move on. The definition of a rational exponent. Rational means fraction, by the way. So a rational exponent means a fraction exponent, basically. Now let's read it in the all-powerful mathematical language. The power of a power property shows that a to the power of m over n is equal to a to the power of 1 over n times m. Do you get it? We just broke this up. This part right here, we just broke it up into 2 parts. You know, there's the n on the bottom, that's this part. And the m on the top, that's that part. We broke it in 2 parts. Let me give you a demo of that. Say I had a to the, no, let's not use a. Let's use 125 to the 2/3 power. Do you remember how we broke that in 2 parts yesterday? We broke it into 125 to the 1/3 to the 2nd. Do you get what I'm saying? That's all they're saying in that mathematical language, is that you can break a power like this into 2 parts. Let's go back and read it a little bit more. Be on this screen right now, please. And a to the m over n equals m sorry, a to the m, oh man, this is difficult to read, to the power of 1 over n. Which is another option. You could take a to the m over n and break it up this way. You get how I told you the roots are on the bottom? The n, that's the root. So we could do that with a root symbol too. All right. One thing they threw in, a needs to be bigger than 0. Look back at the problem and see, why does a need to be bigger than 0? What would get messed up if it wasn't? What if it was negative? If it was an even root, then you couldn't do it because you'd have a negative underneath a square root. All right, one more example. X to the 4th equals, put it on a blank sheet, please. Find a blank notability doc right now. Add in a page is all I'm saying. And get this. There. X to the 4th equals 144. Solve it. I don't expect you to know the number in your head and just go, oh, the answer is 6. It's not 6, by the way. Don't expect you to use a calculator. All right. Why isn't this solved right now? What do I need to fix about it? X to the 4th. What if it was x to the 1st? Would it be solved then? Yes, so how do I get this fixed? I put both to the what power? 1/4 power. And so it's okay to leave your answer like this. X equals 144 to the 1/4 power, but I have just got it wrong. What did I forget? Plus or minus. I just did a square root, kind of. I did a 4th root. Any even root is going to cause this problem where you need to have both answers, plus and minus. Now, what is that answer? If you wanted to check it on a calculator, did somebody already type it in? What is 144 to the power of 1/4? Be careful, you have to put it in with parentheses around the 1/4, otherwise your calculator will think you're doing 144 to the power of 1, and then divide by 4, because it'll do powers before it does divide. So if you don't put parentheses right there, it won't work. What'd you get? So 3.46. What does that really mean? If I take 3.46 times 3.46 times 3.46 times 3.46, I get 144. All right. Let's move on. Everybody find this slide in your presentation. And I would like you, I'm actually going to work the first one for you to remind you how this works. You go 8 to the 1/3 to the 2nd. Even though we just read that property that says you could do it the other way, you could put a 2 here and a 1/3 on the outside, but that'd be dumb. Why would you want to make it really big first? 8 squared is 64, and then have to take the cube root of 64. Pain in the neck. Instead, you should probably do it this way. 8 to the 1/3 to the 2nd. By the way, 8 to the 1/3 is 2, and all of these numbers that I have on the screen here, they're all easy to figure out in your head. No calculators for this. 8 to the 1/3 is 2. 2 squared is 4. I would like you to, for the first 3 of them, to humor me and write it out like this, because I think it's really going to help you. And then you can give the answer. On the last one, if you just want to do it in your head, go ahead. I'm going to pause for a second while I come around and check on you. I'm ready. And the final answer on that one? Because this came out to 4 and, wait a minute. 1/4, no, that came out to 2, right? And then 2 cubed is 8. All right, raise your hand if you had the same thing. Okay, good. Go ahead. And this is an example, just for a moment. Imagine I did this backwards. 4 to the 5th, and then you take the square root of that. Would you like to figure out 4 to the 5th? Ugh. And then take the square root of that. It'd give you the same answer as what she did. 4 to the 1/2 to the 5th. Do you get how doing it in the right order makes a big deal? Makes a big difference? All right, so that becomes 2 to the 5th. What'd you get? You are so right in the next one. How about we just do this one in our head then? So first I do it to the 1/5 power, which would be what? 2, and then to the 4th, which is 16. Good. And this last one, what do I do first in my head? The cube root of 27, otherwise known as 27 to the 1/3, and that would be 3 squared is? Perfect. Raise your hand if you had them all right. Awesome. On to this next kind. X to the 2/3 equals 4. Solve it. In your head. This one works out nice. Yes, ma'am. Yes. Hold on just a second. Let me pause. Okay, I hope what you did was this. To the 3/2 power. Raise your hand if you did that right. Okay, awesome. Now, what is 4 to the 3/2? That's really 4 to the 1/2 to the 3rd. It's exactly what we just did. And that's the square root of 4, which is 2, and 2 to the 3rd is 8. And why, when I do this, will I get the answer wrong? Did anybody recognize it? Yes? There's 2 solutions. Did anybody even notice that? So there goes a 1/2 point on 3/4 of the class. Are you getting what I'm saying? That's really easy to miss. We just did a square root. See? That's a square root. We just did a square root to both sides. If you do a square root to both sides, you're going to get 2 answers. It's just the same as if I had done a square root this way. Having that little 2 on the bottom is a square root. Try not to forget that. It's really easy to forget. I forgot it last year when I taught this stuff. I forgot that I was doing square roots on both sides because I was thinking, well, these are fraction exponents. There's no square roots. Yes, there is. All right, so easy to forget. So what do? Well, technically, I have the absolute value of x equals this. And then the absolute value means whatever's underneath here can be plus or minus. And so therefore, the final answer comes out to be plus and minus 8. If you forget the plus minus, bing! It is only a 1/2 point in this class. Next year, it's just wrong if you forget something like that. Okay, but you know what? If your tests are only worth, like, let's say a test is worth 15 points, and you lose a 1/2 point. Okay, that's 5% or so. Well, let me think. 1% would be 1 point. Okay, it's a third of it's a 3%, 3.3% off your test for getting a negative like that. You forget 2 of them, you're all of a sudden you've lost 7% off your test. That kind of stinks. So be careful with those. On this one, when I do to the 1/3 power, which I know you know, do you need to do the plus minus thing or not? No, because it's an odd root. It's only the even roots that cause that. So this is not an absolute value kind. This is just regular, and the answer is 1/3 power 27. That must be 3. Raise your hand if you have that or knew that. Okay, good. On to the next one. This one we just put both of them to the what power? 3rd. If I put something to the 3rd power, does that cause a problem? Nope. Putting something to a not fraction power, like putting something to the 2nd or the 3rd or the 4th or the 5th, that never brings in the absolute values. It's only square roots or even roots. So this one's x equals 27. Moving on to this one. We're going to put both sides to the what? Go ahead, do that one. Actually, is that the same one as the one before? Sorry, flaw in the smart board. Try that one. This will be better. A little different. What's first step? Add 8. Yep, just add 8. And then you can do the problem exactly like the last one. Lesson's kind of long today, folks. Sorry about that, but a lot to learn. Okay, so Mr. P, tell me what to do. Yep, final answer. Ooh, we remembered the plus or minus. How many of you remembered the plus or minus? Ooh, we're up to 3/4 of the class. Okay, plus or minus, and we do the 9 to the 1/2 power first, which would be 3, and then 3 to the 3rd is 27. Very nice. All right, Because we did a square root, see, on both sides. All right, let's move on. This one, just tell me what to do. How do I start? Minus 8 from both sides. Then put both sides to the power of what? To the fourth power. Good enough. This one, getting a little more intense. How do I start? Add 7. 3x minus 3 to the 3 halves equals 27. Now I'm going to put both sides to the power of what? 2/3. Does that cause the root thing? Like, does it cause the absolute values, plus and minus, all that stuff, or not? No, because it's what kind of a root? This is a cubed root. Any odd roots, they don't give us trouble. All right. So 3x minus 3 equals, cube root of 27 is 3, and then 3 squared is 9. See, I had to do that all in my head? All right. Now what? Add 3x equals 12, x equals 4. Notice no plus minus. Why? Because this was an odd root on both sides. Okay, moving on to that one. Try it yourself. I showed you the other one. You try this one. This is getting into the kind that you're going to have a lot of on today's homework. Okay, I have a student who's going to do this one on the board. You can check and see if you did it as well as she did. I feel like I'm at a golf match. See, at this point in the problem, she's already added 5 to both sides of the problem. It appears that she's squaring both sides. We'll see if she remembers that absolute value thing or not. Oh, wait a minute. When you're squaring both sides, you don't have to do absolute values, do you? All right. Looks like she added 4 to both sides of the problem, and 49 became 53. That was good. She's leaving her answer as an improper fraction. It's unusual, but I think we're going to accept it. Very nice. Golf clap, everybody. Golf clap. Very nice. Okay. On to this one. That one's a little unusual. How am I going to get rid of those square roots? Can you square both sides without fear?
No.
Maybe you're afraid, but I'm not afraid. You can square both sides. It's okay. Watch. Squaring both sides. Does the squaring cancel out a square root? Absolutely. They're opposites. Kind of like multiply cancels out divide. It does kind of. So right now there's no absolute values. Remember, we didn't square root both sides. The problem came with a square root. If I had square rooted both sides, then I'd be worried about absolute values. I am squaring both sides. I have no problems with absolute values. It's just 3x plus 2 equals 9x minus 10. It's squaring. That negative disappears. Do you agree on negative times a negative makes a positive? All right. So, look, Mom, I got a nice easy problem. See? There's no square roots anymore. There is a catch to this problem, but it's not yet. Keep going. Keep going. Get your answer. Mr. E, what did you get for an answer? X equals 1. Raise your hand if you agree with him. Quite a few people said 1. So now, yeah, you're unsure. But now you see other smart kids have the answer. You're good with it. Okay. But now, have you actually checked that answer to see if it worked?
No, I have not.
If you had an evil tyrant boss like Saddam Hussein, and he was going to take off your head if this was the wrong answer, because he does not abide any mistakes, would you check it first before you walked into his office and he's smoking a cigar and looking at you with the big scary mustache? All right, how would you check it?
I would put it into the
If you put in a 1 right there and I put in a 1 right there, watch what's going to happen. This side, everything's fine. 3 times the square root of 3, 3 times 1 is 3 plus 2 is 5. Square root of 5, negative square root of 5. Over on this side, if I put in a 1 on that other side, I have square root of 9 minus 10, which is negative 1. That's an imaginary answer. You're telling me you'll give me an imaginary answer?
Yeah.
He's not very happy right now. Okay, so if this happens on the test, what are you supposed to say? Did it work or did it not work? Does that look like it worked to you? That doesn't look right to me. So you followed all the right rules and yet you still got an answer that was wrong. Can that happen in math? Yes. Will it happen on your test? Probably. Math teachers like to throw in the exception to the rule. So if you followed all the right rules and everything, and it can still come out to the wrong answer. That is called an extraneous solution. You write EXT and you cross it out. Okay. All right. Okay. Well, let's see. Tell me what you did to get 2. I'm curious. Did you agree with that part? 3x plus 2 equals 9x minus 10. Then what did you do? Subtracted 3x. I would agree with that. And what did you get then? Okay, now what did you do? Okay, that makes 12 equals 6x. Oh, man. What did you do? But
You guys broke it. No, there's a negative. Well, there's a negative. So you add 3x to both sides, not subtract.
But that was the, like,
No, but it's not. Yeah, there's a negative.
Ah, you saw this negative in the problem. Okay. All right. Hold on just a second. Let's finish this off.
Negative
X equals 2. When you square both sides, doesn't a negative times a negative make a positive and therefore disappear?
You got it wrong too, Alex.
Yeah, he's the one who gave you this false sense of security that you were right. All right. And there was another hand up in front here from another A student that had 1 also. So don't feel bad. All right, so now, are we confident that 2 is right?
No, it's not.
Wait a minute.
Still not.
Okay, so 2, we get all the way to the end. He's still trying to salvage his pride here. I was right even though I was wrong. Okay, so x equals 2. Let's check. Put a 2 in right here. 2 in right here. And this becomes 6 plus 2 is 8. Square root of 8. Negative square root of 8 is equal to 18 minus 10. Square root of 18 minus 10 will be square root of 8. Are you saying that the negative square root of 8 is equal to the square root of 8? Doesn't work. Now, do you believe in profiling? Do you believe in profiling? That's my question. Profiling is where you, for instance, are watching one kind of customer in your store versus another kind of customer. I'll give you a different example. On your way into the Metrodome, you got a guy walking up with a great big jacket, like big enough jacket that you could hide a small child underneath it. And you got somebody else who's walking up with a skin-tight t-shirt on. Which one do they frisk? The guy with the big jacket on, because they're making sure he's not carrying something into the football game or whatever that's not allowed. Okay? So we're going to profile these problems. The problems you have to worry about are problems that have square roots in them. Because the problems with square roots in them are the ones that often crash. Do they always crash? No. Are they the type of problem that you have to watch out for? Yes. So do you have to, from now on, check every single problem that you ever do by taking the answer and plugging it back in? No. But I would profile the ones that have square roots, because a lot of times you end up getting answers with negative square roots. Okay? Just like the guy with the big baggy coat. Profile them. All right, moving on. This is just a reminder of yesterday. We did base change. Remember how the bases here are not the same, but we could make them the same? Do it. Solve this by doing a base change. That's already a 2. Doesn't need to change. But that one does. give you another example of in Chicago lately, they've been having flash mobs, and in the middle of a normal evening, all of a sudden, like 23 teenagers run into your store. That make you nervous at all? It should, if you haven't seen these videos. These flash mobs run like 13, 15 kids into the store, grab stuff off the shelves and turn and run out, because they figure they can't stop them. If there's that many of them, the store clerk won't know what to do. And so that's another time when you have to be like extra careful of what's going on. They showed one guy trying to like lock them into his store. He shut the doors and tried to like lock the doors and like hold them into the store, well, because he called the cops. Couldn't hold them in. There's too many of them. They just pushed them out and pushed out onto the street. So it's happening a lot in big cities. All right, this 16, I hope you rewrote it as 2 to the 4th. Then that equals that. 2x equals 4. X equals 2. Raise your hand if you had that one right. Okay, good. Moving on. This one, let's not keep doing these. This is base change from yesterday. You would change both of these into 4 to a power, probably. This would be 4 to the negative 1 to the 2x, and 4 to the negative 2. And then you could say that equals that. All right, let's move on, though, to the new stuff. There's some more new material here. 4 to the x times 4 to the 3. If there's no multiplication, we can assume that there's a multiplication right there. Equals 4 to the 7th. What do we know about bases? If they're the same, you can. Yes, you can put the exponents together. In this case, do we multiply them or add them? So, what are you saying I should write? X plus 3 equals 7. You get that? Because in this situation, we would not multiply the exponents. If I was going to put these guys together, I could add them together. In fact, some people would start this problem this way. They'd say 4 to the x times 4 to the 3rd makes 4 to the x plus 3 equals 4 to the 7. You see how then it's maybe a little easier to just say that equals that? Make sense to you? Okay, moving on. This one, what am I going to do to those powers? Say a little louder. Not the answer. What am I going to do to the powers? Subtract them. Very good. So x minus 3 has to equal 7. And then do you get that the answer has to be 10? And I know you could have just looked at this one and said, oh, it's got to be 10. And that's okay, too. All right. This one. We just talked about these before. How do I fix this so that the x is alone, so to speak? Put it to the what power? Negative 1 power. Good. Because negative 1 times negative 1 will make a positive 1. And if it's x to the positive 1, you're all good. And then negative, wait a minute, what does a negative 1 do to something? It's like, what's this answer here? Just flips it, so the answer's 5. Okay. This one. Are those x's on the bottom happy there? Move them up, make them happy. Simplify your 5 and your 10. Once you've got some simplifying done, rewrite your equation. Then see if you can solve it. In the back row, Mr. S, tell me how to start. I agreed. Make them what? 1 and a 2. Perfect. Now what? Excellent. Rewrite that whole side then. Perfect. And now what? X to the 5th equals 32. Now what? Okay, but you put it to the, this is important, put it to the what power? Did you just do a square root on both sides? No. What root did you do? You did the 5th root. Is that the kind we have to worry about, the plus minus thing? No. So this one, some of you never even thought about it. But when you did this, when you did the 5th root, that was an okay one because it was an odd one. That's equals 2. Otherwise, if it had been an even root, we'd have said plus and minus 2. Raise your hand if you had 2 for that answer. Okay, good. Moving on. This one, they're getting a little more intense. All we got to do, though, is simplify these. Put these all together. It won't be too hard. The only trick here is, wait a minute, there's y's in there. If there's y's in there, and I don't tell you what y is, unless that you have to get lucky and they all cancel, which they won't, then that means you're just going to have a y in your answer. This is called a literal equation. A literal equation, when you solve it, it still has a variable in it. I know that annoys kids. They want to have an answer like 6, but this will have an answer like 6 plus y, something like that. That's not the answer. No. So some stuff you can do. Haven't I picked on yet? Mr. H, tell me what, give me something to do here. Sorry, the one in the black t-shirt. Trying to not use names over the video. Go ahead. Okay, and that would become a 1 and a, excellent. Now what? Can you put some other stuff together? Give you a hint. Those go together. Yeah, keep going. Excellent. What do you think you get then? What's on the top? Good. Over. Perfect. Hand it off to somebody else. Anyone? All right. Times by 4 on both sides. I can agree with that. Except I'd really rather get rid of the y to the 6th at the same time. So times by y to the 6th also. That way, that whole thing cancels that whole thing. And I get the x's almost alone. 2 times 4 is 8, y to the 6th. Now what? Cube root, very good. Is the cube root the kind you have to worry about or not? Nope, no worries there, because it's not an even root. We just did the 1/3 power there so that the x would be to the 1 now. And I'm good, it's done. I just have to actually do that. What is this 1/3 power? Is 8 to the 1/3 doable? Can you do that? Yeah, what is it? 2 is 6 and the 1/3. What should I do that when there's a power and a power like that right next to each other? Do I multiply them or add them? Multiply them. What's 6 times 1/3? Did anybody have 2y squared? Raise your hand if you did. All right, only have 5 people, but nice job, those of you that had it. That was a tough one. Trust yourself. Trust yourself. All right, I think we have done enough. That last problem is overkill. That was a lot to learn, but we've covered it really thoroughly. That means that I know you were with me too, because I was watching. So I really think you're well prepared for tonight's homework. Given the fact that we don't have that much time, though, I would like you to pull up the homework, and I'm going to tell you a few problems to skip, because my deal is still that I only want to assign homework as reasonable. And let me take a look at it. That's all I have for the video for today.